Welcome back to our third session, how to build Blackjack using Python. Now, at this stage we managed to compose a few classes. We know how to construct playing cards, we know how to put them into a deck of cards, and we are able to reshuffle the deck of cards. Then we designed a few tests to make sure that even after building more and more classes, that the classes we designed actually work and they do what they are supposed to do. So now, of course, we are at a point where we have to think what next. So we have a deck of cards. We reshuffle the deck of cards, then we could actually start giving cards to players. And in Blackjack, in the first round, you would give to each player 2 cards, including the bank. At the moment we ignore the bank for the time being. We try to work on this a bit later because there are a few difficulties, and we try to introduce now players. We need somehow a class that would store information related to a player. So again, I recommend that we import the player class into the main, and we just start with a new file here. That's the main one. We just add one more file, and I just again do a doc string here. Determines player class, and consistent with previous definitions, I just call this here player.py. So that is a good start. Then right away I actually start now building my test as well. I just take one of these tests because it's quite similar, and I save that as test player. That's fine. So that should be my player later. So it tests here the player class. We haven't actually done anything yet. It would import player from player. We definitely will do some testing on attributes, and we call this here the player test. Let me just remove some of it. Now the first thing you would expect is that the player obviously has somehow a way to be identified. The obvious thing to do is to actually give the player a name. You know, that is kind of quite useful, I guess. So the first test could test whether the player has a name. So has name. Yeah. So when I initialize here a player, we could do something like this, where we have a player class, and then we would just type in name, and we would give it a name. I just give it a random name, say Tom. Yeah, doesn't really matter. And then below we would simply assert equal our player instance dot name, which should be equal to Tom. Yeah. So what you notice here, I actually wrote the test before building the class, and this is actually a certain principle of software development. So if you're quite strict on it, that would be test-driven development. So you basically design a test first, so you basically define what this class is supposed to do, and you write your tests for it, and then you actually run the test, which of course by default will fail, and then step by step you try to address the errors, and you try to get the new class to the standard you want. So now we in fact could do that. So if I can just copy paste my command here and run my tests, let's see what happens. Well, of course, obviously you get an issue. There's one error, so one test doesn't work as we expect. And the first thing is an import error, cannot import name player from player. Okay, so that's the first test. Good. Let's go into player and fix that particular test. Let's do that. Okay, it's easy. Class player. That would actually already do it, and I just put a pass here. And let's run the test again. Here we are. We get the next error message. Okay, so you see in line 11, player takes no arguments. Okay, player takes no arguments. Okay, what do we have to do? Obviously, we have to do our dunder init and define an argument, which I then call hopefully name. If I give it a different name, of course, I would get another error. Yeah, and I say self.name is equal to name. Yeah, so that should do it. Now, if we run this again, let's see. Now it passes. Yeah, so that would be a test-driven development approach. I'm not really super strict on this for these quite easy classes, but sometimes this can be useful. In particular, if you don't quite know how to design a class, it's quite a sensible approach to think, okay, what is it supposed to do? Write some tests for it, and then start building from the tests, from actually test failures, a correct class that would actually pass all these requirements. Now, what else do I want the player to do? It's kind of useful to give cards to the player. Now you have to think how I store this information. Ideally, you do this on an attribute, yeah, because you can update the attributes over time. You can start with a certain value, and then you can change the value after one or two cards are dealt, and then you could just store this on an attribute. Now, when it comes to cards, storing several cards, the obvious thing to use here is a list. Yeah, the order, you could maybe change the order. It's a possibility. You could argue, do we want to fix the order here? You could do a tuple. There are different things you could consider, but I think a list is kind of quite a plausible starting point. Yeah, so here we could start with self dot, and let's call this a hand. Yeah, so you have, of course, a hand. That's a term used in gambling. So your hand is basically the cards you have as a player, and you can start just with an empty list because you initially don't have any, and then in the first game round you get 2 cards dealt to you. Yeah, so that makes sense. Now I can start also developing my test a bit further, and well, yeah, let's put it in here. Let's do that and say has a hand, and initially I can stick to the same name, it doesn't matter, but I now refer to my hand attribute, and of course it should be, fingers crossed, an empty list. Yeah, so we have done that. We can run this again, and it's passing. That's fine. Good. Now, what else would be useful to have? Now, quite often when you think about how you will later interact with a player, it would be definitely useful to show a player what hand the player has. Yeah, because in the end, the player has to make a decision, do you want to take one more card or not? So that's an obvious thing to do. It would be maybe also useful, just out of convenience, to provide the score. So we would basically take the hand, calculate from the hand the value, which we already implemented in our cards class as a property. But we already know there is a difficulty when we have an ace as well, because an ace could be an 11, but it could also be a 1, so you might have a soft or a so-called hard hand in blackjack. So this is something that we have to think a bit more about this. But what we can certainly do is we can just simply store the current score on the player as an attribute, initially, of course, your score is simply 0 because you have no cards. Yeah, so that's perfectly fine. So that would make sense. Okay, so that's it, and let's implement it here as well. And we just say has score, and again I can just stick to the same name. I can also of course change it as you wish. Let's just change it to Sue. That's fine, and we refer here to score, and the score should be 0. Okay, let's do that, and I run it again, and it's of course passing. That's fine. Good. What else would be nice and useful? Well, of course, now when we import our player, let's just do this maybe first. Import player in our main, and further down here we just initialize a player. Let's do that. I just call this now start game. We'll come to this in a second. And I call this player simply player, and is equal to player, and of course when I have to give it an attribute, the name, I just say Amy. If I do something like this, print player, of course nothing useful really happens. Yeah, so if you do that and you run this, so python main.py, you would simply get the fact that this is a player object, and you get a funny number. This is basically where this is stored in memory, so that's not very useful. So again, it might be useful to have a technical representation in this particular case. I think that might be good, so that makes it easy then to display player, because then you can say actually what does player do, what does it stand for. So let's implement this in our player class. We can do a def dunder representation self. Here we are, and I want this to return a formatted string. We have used something similar before, so we have in front then the quotation marks. And what do we want it to say? Well, I think it might be useful to say, okay, self.name. So it will give you the name, and it gives you maybe the score. Has score and self.score. That should do it. So when we now run this again, we get Amy has score 0. Yeah, so that is quite useful. Good. And now maybe get rid of the print command here and here. We don't necessarily need that. We know it works. So we run this again, and we see Amy has score 0. Okay, that's great. Good. Again, we go into the tests, and what we do now is we just check, does it actually work? Obviously, now these tests will be fine because we just worked on it, but I promise you, if you have 20, 30 different classes and you have a bug at one point and you start fixing it, and by accident you make some changes to another class and you don't think about the consequences, it's really, really good to have these tests because it's so easy to make mistakes. So just call this representation. So has representation. Okay, I can stick to Sue if I want to, that's fine. And I would simply then go in here and use the representation function and pass in player, and that should give me whatever I said it should give me. And it would be in this case Sue has score 0. Yeah, this is what I have done. Okay, let me see. Okay, it's passing, so that's good. Yeah, so that's all fine. So we have now a working player class. We have our tests for player implemented, which is quite useful. Now what else should we do? Well, now the interesting thing is to start the actual game. Now I could, in principle, start playing the game in the main.py. Yeah, that is possible. I can actually do that as well. But I think all the game structure and function, it's better because it gets quite busy very quickly to have a separate class for that. So I do another class here, which I call the actual game class. Yeah, so this is here determines the game class. So that's fine. Let's save that as simply game.py. So that's it, and let's just throw in class game and just at this point do a simple pass, and we can also now save that here as a test for game.py, and that is testing the game class. I would import from game, import game, and then I would do something like this. I get rid of all of that. So now we have initialized that, we have our player here. I can close this, we don't need the deck. Let's go back here. So that seems to be making sense. And I import in main my game class. Okay, now the thing is, what should this game class do? Actually, this should basically play the game for me. Yeah, so the first thing that might be maybe useful is that when you initialize the game, it might be useful to contain the players in this game. Yeah, so when we do our game, it would be helpful to do a dunder init, initialize that with an attribute to simply store the players. Yeah, I just call this self players, so using the plural. Again, it's quite useful to use a list for that. Yeah, so just put here an empty list. So it's just a way to a container. So once I start the game, it would have this attribute. Initially, of course, there are no players, but then I start adding players. And then we have to think actually how do we add the players. And this depends, of course, on how we interact with our game. Yeah, and there are different ways of doing this, but we will come to this in a few moments. Okay, so again we check now in our test game that the game actually has players. So let me just do this, has players. So I initialize a game and I put it in here. So game, oops, that won't work, players, and we just assume this should be empty first, and then of course we have to start adding players and so on. Let me just check that as well. So that looks okay. Let me run this and it passes. Yeah, so the convenience you now notice, because now we have several files where we do some tests, but it's not really easy to execute all of them in one go. It's much better than doing this test by test. Yeah? And quite often, as I said, it's easy to overlook interdependencies. Yeah? So that is I can be now quite confident that the changes we made did not have any negative impact on other classes. You know, that seems to be quite fine. Okay, so that's a nice start. Now, of course, well, we now have to start adding the players, don't we? Of course, that's obvious. Now, how can we do this? Well, the place to do it, I think, again, you can do it differently, would be in our game class. So here we can do an instance method where we say, okay, let's call this add players, or add player. Just let's do a similar, because we could be player at a time. Self, and then I pass in here player. Now there are different ways to think about this at this point. So you could basically, so if I do it this way, what that actually means is I have to initialize the player first somehow, and I call this instance player, because that's not the class. Yeah, you might remember before in our deck class we simply use as an argument card, the card class. Yeah, that is different here, and I think it might work better, but we have to figure it out. It depends a bit on how we interact with our game. I could also make a note here, because I'm not yet sure how I do this. So if you, for instance, build a graphical user interface, you could have a button to add one player at a time. Yeah, it could be a button, for instance, if you do a GUI. If you play this in your terminal, you might have a prompt asking you how many players do you want to add, and then it might ask you what's the name of the player. Yeah, so I think that's just a note for us. We have to work on this a bit more. But obviously what I want is I want to pass in the player. So I go to the attribute players, which is an empty list, so I can use the append method on it, and I pass in player. Yeah. Now of course this particular class does not have to understand the player class. Yeah, so it's not important in this particular case. Now in your tests it actually would make a difference. There are different ways of testing now. What I do here is maybe not the best thing to do, because what you could do instead is you can use a mock object, but this is a little bit more technical. Because ideally, as I said before, it's nice to isolate the different classes you build, or the different functions you build, to make sure that if something goes wrong, you're able to pinpoint to the problem. So this is why sometimes having a mock object is better than the actual object, but this requires more work, and I think it's not necessarily worth it in this particular case. So what I do instead is I just introduce the player class into our test, and in our test what we do is we actually initialize a player. Yeah, so let's do this test, and how do we call this, maybe adds player. And as we have to check, does it actually add a player. So first we need for this to work, we actually need a player. So let me just do this, and we can call the player as we want. Say Amy, whatever, and we would then start our game, so that's fine. After we have the game, we have to of course then call the instance method. Yeah, so we do game dot, and it is at player, and we pass in player. Yeah, good. So hopefully then we should see player in here. Yeah, so this is how I would expect that. So if I go into game players, which would give me a list, you should now see the actual object player in the list. Yeah, so that would be the proper test. Yeah, so because this object here, player, is passed into my instance method, and the instance method simply appends the list, so it should be there in the list. So that would be a suitable test for that. Let me just try, and it does pass, so that's good. Okay, so now we can add players to the game, which is useful. That's quite a good start. What else would be useful? It might be now, of course, a good thing here in my main file to actually start the game. Yeah, so we have a player here. We have player Amy. So that is fine. It's useful. We also have to start the game, so we initialize game here, so that's good, and we have a player. We can print the player, that is okay. Then we can call our instance method, so we can do game.add player, and we add here our player, that's fine. And then we could also print that off if we want to. And fingers crossed that should work. Yeah, I now get rid of a few of these things because we don't really need that. So we have a deck up here. We add some cards. I just keep that info for the time being, and then we reshuffle it. Okay, that's okay, and we then start the game. Let's just do that. Okay, let me run this again, and that looks fine. So the first print is just the technical representation of the player. So Amy has score 0, that's fine, and late, of course, that's part of my list. Yeah, and this is exactly what you see, so that works quite well. Good, so now we have our player class, we have the beginning of the game class. Now the next step is to actually distribute the first 2 cards to the players, and then check what is the score. So that's the next step. Yeah, so I'll see you next time.